Hi all, I'm Dr. Sijya, Assistant Professor in the Department of Computer Application at Dr. SNS Rajalakshmi College of Arts and Science. And today the video I'm going to discuss is about stacks in data structures. And stack is a linear data type which follows the concept of last in first out, which is simply called as LIFO principle, where the last elements inserted in the first will be dropped out or popped out, or it will be deleted. It means both the insertion and deletion happens at the only one end. So in this diagram it is clearly shown that ABC is being inserted into the stack in the sequential form, where if you want to delete an item from the stack, so the first element C has entered into the stack, that will be popped out first. After C is popped out, then B is popped out, and then A is popped out. So the element which has entered into last of the stack will be pushed out, will be popped out from the stack, and the top pointer will be pointing out on the first element which is inserted into the stack. So this is the overall structure of the stack in data structure. So the operations that has been performed in stacks are push and pop operation. So it has been given that the capacity of the stack is 5 and the top is fixed to -1. So this shows that the top is empty, so the elements can be inserted into a stack, and the elements and the numbers which is mentioned as 0, 1, 2, 3, 4 mentions the index of the stack. So suppose if you want to push an element 5, then we have to check whether what is the capacity of the stack, and then we have to check whether the top is -1. So this top is -1 indicates that the stack is empty. So once we confirm that the stack is empty, then we have to increment the top to 1. So from -1 it will be moved on to 0. So once it is indicated as 0th index, then the element of 5 will be inserted in the 0th index, and then if you want to push element 9, in such a case we have to increment the top. So the top will be incremented from 0 to 1, which indicates that the element 9 will be pushed into the index number 1. Then on the next iteration we want to push 10. In such a case it will be checking for the capacity, and as well we have to increment the top to next position, that is top of 2. Then we have to insert an element of 7. Then we have to insert another element, that is 4. In such a case we have to check the capacity, that is 5. Then we have to increment the top to 1, so it will reach the index of 5. And finally the stack capacity has reached to 5. Suppose if you want to push an element 10, then it will give a message as stack overflow, which means it will say that the capacity of 5 is filled with an element and you cannot insert a new element. So in such a case it will give an error message as stack overflow. And one more drawback and one more limitations we have in stack is we cannot remove an element in middle, or we cannot remove an element in the last. It is in the sequential form and it is in the linear form. So the elements which comes at the last can be removed at the first. So this is a zero code for inserting and deleting an item in a stack. So first we have to operate a push operation. Hint data. So hint data where the data has been inserted, and first inserting a data we have to check whether the stack is full or not. If the stack is full, it has to print a message as stack overflow, and then we have to come to the top of the data. In case if the stack is empty, then we have to give the statement as stack underflow. Only performing these conditions, that is we have to check whether the stack is full or stack is empty, only then we can perform certain operations. So this is what is of push and pop operation in a stack function. So this is a time to think, where we have to check for the capacity of 5, and then we have to increment the top pointer to 4, and then once the top pointer 4 has been reached, we cannot increment an element. In such a case, here it is asking for an element to pop as 9. So 9 is present in the index of 1. So only when 5 of the index 0 is eliminated or popped out, only then we can delete the index number of 9. So this is not possible as it is in the sequential flow. So this is of pop operation. That pop is performed based on the capacity. So pop operations where the last element which is entered in index 4 will be popped out first, and then 4 will be popped out from the index 3, then 7 will be popped out from the index 2, and so on. This is how a pop function is performed. So this is an animation video of how a stack is being performed. So just check, 12 is the first element that has been inserted into a stack, then 2, and then 0. So this is performed by using push operation, then 6. Now we have to pop out an element. So the element which is inserted lastly will be popped out first, then 0, and again 0, and then 2, and then last element 12 will be popped out. So this is how a stack is performed. So finally, if the stack is, so this is how an operation is being performed in a stack. So the real world example where stack is used is of arranging plates, where the plate which is arranged last can be popped out first. Book arranged vertically, then browser's back button. The last visited page is popped first when we use the back button. Undo redo operations in a Photoshop, mobile application screen navigation, and call stacks in phones and computers, game moving histories in chess, and browsing histories in applications. So these are the popular real world applications where a stack is used. Thank you.